In this tutorial we're looking at section 9.3, which is solving type 1 differential equations. So generally speaking, if we're going to solve a differential equation, well, that involves integration. Okay, our general solutions don't require the constant of integration to be found. So remember, whenever we integrate a function, we end up with that plus c on the end. That's our constant of integration. So our general solutions are fine with that plus c being at the end. Particular solutions require the use of some other information in order to find the value or values of the constant or constants of integration. So if we're a first order differential equation, so we're only using dy dx, then we're only going to integrate once. However, if we're doing a second order differential equation where we've got d squared y on dx squared, we're going to integrate twice. We're going to end up with two constants of integration, which means we need two bits of information for a particular solution to be able to be found. So again, in general, the number of constants that you need to find is equal to the order of the differential equation. Okay, so we're worried about type 1 differential equations in this section, which is in the form of dy dx equals f of x, and we simply rearrange and then integrate these ones. So we'll demonstrate this through a few worked examples. Okay, so worked example 4 is find the general solution to dy dx equals dy dx plus 12x equals 0. Okay, so what we do is we rearrange it to make it dy dx equals minus 12x. So y is equal to the integral of minus 12x dx. Okay, so that means that y is equal to negative 6x squared plus c. And that's all there is to it. Okay, for that first one. Okay, we want to find the particular solution to dy dx plus 6x squared equals 0, given that y1 equals 2. So again, we say dy dx equals minus 6x squared. Okay, which means that y equals the integral of minus 6x squared dx. So y is going to equal our minus 2x cubed plus c. Right? Now we know if we sub 1 into the equation, it's going to give us 2. So we can say that 2 is equal to minus 2 times 1 cubed plus c. So 2 equals minus 2 plus c. Okay, so we'll add on our 2, means c equals 4. Okay, therefore our solution is going to be our y equals minus 2x cubed plus 4, or as I've got in the book, y equals 4 minus 2x cubed. Okay, just putting the 4 first. Okay, so we'll keep going. We've got some more worked examples to look at. So what we can need to do is some of our substitution work that we've done previously to find some of our integrals. So what we need to do is we need to rearrange this equation. Okay, so what we can do is we'd be able to subtract 1 and divide by our 4 minus 3x all squared. So we can say then our dy dx is equal to our minus 1 over 4 minus 3x squared. Okay, so that means then if we want to find y, well, we've got to say y is the integral of minus 1 over 4 minus 3x squared dx. Okay, so what we're going to do is we're going to say let u equal 4 minus 3x. Okay, well, our du dx is equal to minus 3. That means our dx on du is equal to minus 1 on 3. So dx is equal to minus 1 on 3 du. Okay, so we can put that back into our equation here and say, well, y is equal to minus u to the minus 2. Okay, so just putting u in for here now and bringing it up as a negative power. Okay, times by minus a third du. Okay, well, we can bring out our negative and our negative cancel out, and we bring the third out the front. So say y equals 1 on 3 times the integral of u to the negative 2 du. Okay, so y equals a negative a third u to the negative 1 plus c. Okay, or we can say, well, y is equal to negative 1 over 3u plus c. Okay, so we need to sub our u back in. So you say, well, y equals our negative 1 over our 3 times our u, which was 4 minus 3x plus c. Okay, now we know that we've got this point y of 1 equals 2, so we sub x equals 1 into our equation and let y equal 2. So we say 2 equals minus 1 over 3 times 4 minus 3 times 1. Okay, plus c. Yeah. Okay, so we get 2 equals our minus 1 over, well, 4 take 3 is 1. So it's over 3 plus c. Okay, which means we get 2 plus a third equals c, which we can write as c equals 7 on 3. Okay, so that means then our y equals minus 1 over 3 times 4 minus 3x, 8 plus 7 over 3. Okay, what they do is they simplify the solution. Okay. But look, I wouldn't worry too much about simplifying it down too much. Okay, but you can actually, you could bring it, do your cross multiplication, things like that, so that your denominators are the same and you can simplify, which means what you end up getting is y equals our 9 minus 7x over 4 minus 3x. Okay, yeah, so that's by combining those two fractions. Again, as I said, I probably won't worry too much about doing that. That would be an acceptable form of the solution for that one. Okay, our next worked example, we've got 2 to go. It's worked example 6. Okay, so that's solve the differential equation, square root of 3x minus 5 dy dx plus 6 equals 0, where y of 7 equals 2, and we need to state the maximal domain for which the solution is valid. Okay, so that last bit doesn't come into it till the very end. Okay, so we just go through it as we would. Okay, so what we're going to do is we're going to rearrange. So we're going to take away 6 and divide by our square root part here. So we can straight away say our dy dx is equal to minus 6 over the square root of 3x minus 5. Okay, which means our y is equal to the integral of our minus 6 over 3, the square root of 3x minus 5 dx. Okay, well what we can do is we can bring our minus 6 out the front. Okay, make it minus 6 times the integral of 3x minus 5 to the negative a half dx. So we can just express our 1 over the square root of 3x take 5 as our 3x take 5 to the power negative a half. Okay, then we're going to need to say, well, let u equal 3x minus 5. Our du dx is going to equal 3. So our dx is going to equal 1 on 3 times du. Okay, which means our y equals our minus 6 times our integral of u to the negative a half times a third du. We can bring our third out the front to cancel with our 6 to make it minus 2 times the integral of u to the negative a half du. Okay, so now we can integrate that. So we're going to get, when we do that, we've got our minus 2 times, well we've got to go our new power. Okay, so we've got to increase our power by 1, which will make it positive a half, and then we've got to divide it by that new power, so we've got u to the half over a half. Okay, so y is equal to minus 4 times u to the half, or y equals negative 4 times the square root of our u, which is 3x minus 5. Okay. Oh, and don't forget sorry, we didn't need our du there, we need our plus c, and plus c, and our plus c. Okay, they go through this last little bit in a bit of an odd way. Okay, but don't worry about that, it's just as you would normally do. So now if we let y equal 0, y equals 2 and x equal 7, then we can work out what our c value is. So we say 2 is equal to negative 4 times the square root of 3 times 7 minus 5 plus c. So 2 equals minus 4 times the square root of 3 times 7 is 21, take our 5 is 16. A square root of 16 is 4. 8 times our negative 4 gives us our negative 16 plus c. So c equals 18. So that means that our equation is y equals, we wrote it as 18 minus 4 times the square root of 3x minus 5. Okay, so what we need to do though is have a look back, because we need to work out this maximal domain bit. But what we need to do is look back here and go, well, for this, okay, we needed our 3x minus 5 to be greater than 0. Okay, because if it's a negative, well, we can't take the square root of a negative. If it was 0, then we'd be dividing by 0 and we'd still have a problem. Okay, so that means that we've got to say, well, 3x is greater than 5. So x is greater than 5 on 3. Okay, so we can say here, 4x is greater than 5 on 3. So basically, everything was the same, okay, with what we did with this differential equation. It's just we need to look at any conditions that was required originally for it to be valid, okay, in order for our differential equation, when that's been solved, for it to be valid. Okay, so again, we're just applying our skills of integration. So I've got one more to go. Okay, we've got to solve the differential equation, the square root of 16 minus x squared dy dx plus 2 equals 0. We know that our initial condition is when x equals 0, y will equal 0, and we need to state our maximum valid domain like we did last time. Okay, so what we're going to do is we're going to rearrange like we have been. Okay, so we can subtract our 2, divide by our square root of 16 minus x squared. So we say our dy dx equals our minus 2 over square root of 16 minus x squared. Okay, that means that y is going to be the integral of our minus 2 over the square root of 16 minus x squared dx. Okay, and just simply by integrating that, we should hopefully be starting to get pretty familiar with this. Okay, that this is actually going to be a cos one. Okay, so we use our integral of minus 1 over the square root of a squared minus x squared dx equals our inverse cos of x on a plus c. So we're going to be using this formula here. Okay, to integrate this one, okay, which means we're going to end up with 2 times the inverse cos of x on 4 plus c. Okay, we can let our x and y equal 0. So 0 equals 2 times the inverse cos of 0 plus c. Okay, well, we can say then that our c is going to equal negative 2 times the inverse cos of 0. Okay, inverse cos of 0, okay, is pi on 2. So c is going to equal minus pi. That means that our y is going to equal 2 times the inverse cos of x on 4 minus pi. Okay, we just need to have a quick look at our original function, okay, so that we can see what needs to happen with our domain. So again, we can say, well, we needed this bit to be positive, so our square root of 16 minus x squared needed to be greater than 0. Okay, so that, well, we can look at that and go, well, if we square both sides, we can say 16 minus x squared is still got to be greater than 0. So 16 has got to be less than, sorry, 16 is going to be greater than, if I do it right, our x squared, which means the modulus of x, right, has to be less than 4. And if we take the square root of x squared, it gives us the modulus of x, and the square root of 16 is going to be 4. Okay, so we can then add to our answer here, say where the modulus of x is less than 4. Okay, to finish off. Okay, so really all we're doing differently to what we've done in previous chapters is we've got to rearrange our equation first. To set up our integral takes 2 steps, then we're just integrating using our initial condition to find our c value. All things were done before, okay, and it's just doing this maximum valid domain as well. So again, hopefully you can get through these questions without too many dramas.